So I've been busy prototyping a Yagi antenna that's basically based off the measurements and design of this Yagi antenna that I took a look at a video or so ago, and I just wanted to see what would happen if I shortened the length of this Yagi but added some more parasitic elements in there, top and bottom, so we get this X effect. And I wanted to show you this video because this has turned out to be a cracking little antenna. So in this video then I'm going to be taking it from this prototype version here into making something a little bit more solid that you know, you could use on a daily basis and you know, quite literally won't fall apart. It's not going to be a production Yagi antenna. It's not going to be taken to that kind of level, and I have got some ideas of cutting the elements out of a sheet of metal or sheet of copper, and I'll be doing a future video on that. But it's just at a level where you could make one for yourself and use it, no problem at all, without it falling apart and being held together with sticky tape and cardboard. Now this one's going to be for 2.4 gigahertz, but I am working on a version for the 5.8 gigahertz FPV, and this is a version here, and I've been playing around with this for a while now. It's not based off this design, it's based off a crosshair element design, and again it's a Yagi antenna, but each one of those elements is a crosshair style that feeds the main driven element here, and this has got circular polarization. It's still not ready for me to show you this yet, but it is showing you know, excellent signs that it could turn out to be a cracking antenna. And again, the work that I've been doing on this for the past few months really inspired me with this design as well. So it's just to give you an idea how different antennas can feed into other designs, and you can come up with some completely new idea for an antenna. And you know, this little antenna here is giving gain performances that you would normally get from something like a 8-turn helical antenna. So it's got quite a bit of potential, but again, this is for another video. And as for this design that I'm going to show you today, I've already tried to put this into a waveguide to see if we can get even more gain out of it and you know, more range, but so far I'm not having much luck. I think it may be down to the circumference of the tin that I'm using here as the waveguide. I don't know, but it's not performing as well as it should, and it's certainly not performing as well as this one here without the waveguide. So a little bit more work needs to be done. But again, I know some of you will ask if you know, what will happen if I put this into a waveguide like I did with the Yagi in a can. It's just not working out quite right at the moment, but it is something I'm looking into. So basically then I'm going to be using a lot of the construction techniques that I use in this first prototype here, and I'm just going to be you know, substituting the cardboard here that I'm using for the support for the driven element. We need something a little bit more substantial there, and obviously the masking tape, and also this sticky back foam here, we're going to do away with that as well, just to make something that's a little bit more substantial and won't fall apart by the end of the day. So for the boom for this then, I'm going to use a length of wooden dowling, and this is 6mm in diameter. And to prepare this, I'm going to need to draw two straight lines down the length of the boom here, and I'm going to draw one on the top here, and then turn it a quarter turn, and then draw a second one, and that'll give me the longitude to mark out the holes where I'm going to drill through the dowling, so I can get that cross effect with the elements. So I'm going to do the longitude along here, and then I'll do the latitude, so I can put a little cross on the line that I draw straight along here, and that'll give me the position for the hole to drill straight through. Now the easiest way to draw a straight line down the length of this boom is to get something that's flat like this. I'm using a piece of cork matting, and this is 3mm, so it's half the width of the diameter of this dowling here. You can use a thin piece of plywood, anything like that that's flat. This piece of cork is just there so it doesn't slip. You don't really need that. But what I'm going to do is hold the dowling along the straight edge of this cork mat here, and because it's half the diameter, it'll give me a line in the middle. And also what I can do is rest my pen along here and just drag it along that cork mat, and I should get a nice straight line all the way down the dowling. So I've got the dowling held in place with some duct tape at either end, as you can see, just so I can concentrate on drawing this straight line down the dowling itself, not having to worry too much about the dowling slipping. So now I've turned the dowling a quarter turn just so the black line is on the top here, and then I'm going to draw the second line along down the dowling. So we're going to use the spacing distances then that we got from this Yagi antenna, and in that video I got the spacing measurements mixed up a little bit. I think it was down to probably too much caffeine and not enough sleep, but I've since put an annotation in that video. Now the distance from this first parasitic element to the reflector is 37 millimeters. So what I've done here, I've put a little mark around the dowling here, and that's roughly where I'm going to cut it off. So I'm going to put a little crosshair mark about 5 millimeters in from that on both lines there, and then what I'm going to do, I'm going to take my measurements for the first parasitic from those marks there, because these two marks is where I'm going to drill the holes for the reflector elements. So I'm measuring off 37 millimeters from these two marks here, and just put a little crosshair where those two marks are. So the rest of the parasitic elements are spaced out at 27 millimeters apart. So got it buttered up to these two marks where the first parasitic element's going to go, and just measure off the same again, putting two little marks. So I've got two crosshairs for my drill bit. Now this design is going to be a 4 parasitic element Yagi, so I'm just going to go down until I've got the marks measured off for those as well. So I've got all the marks now where I need to drill, so I'm just going to drill straight through. I'm going to use a drill press, and you know, it's a lot easier with a drill press, but doing something like this with, say, a Dremel is doable. You just really have to take your time and make sure you've got it as straight as possible. But I'm not going to cut the dowling down at this point in time until I've finished working on the boom itself, because it's just a lot easier to handle while it's longer like this. And then when I've got all the holes drilled, then I'll cut the dowling down so it's easier to handle while we're constructing it. So now that all the holes are drilled, I've trimmed the dowling down to the size that we need, and one of the drill holes, which is this one here, is a little bit wonky, but because this is wood, we can easily straighten that out by bending the element once we get it in place. So what I'm going to do now is cut the elements to size using coat hanger wire. So as I said, this is just coat hanger wire. I've just bought you know, some cheap wire coat hangers off eBay. eBay seems to be the only place I can pick wire coat hangers up these days. Any of my local shops or the bigger supermarkets don't seem to sell wire coat hangers anymore, but you can pick them up off eBay pretty cheaply. And what you want to do is cut 4 elements that are 45 millimeters long and 1 element that's 63 millimeters long. Obviously this one's going to be the reflector, and these 4 are going to be the parasitic elements. So to help me glue them in place and get them nice and straight and evenly spaced out, I've just got 2 thin strips of the cork that I used previously. That's about 2 millimeters thick, and you could use card or plywood, as I say, something like that, around 2 millimeters thick. And I've built this jig to hold everything in place. I've got it all tied down to the bench with some masking tape, and that's allowed me to get in with the ruler, make sure that the elements are directly in the middle and all lined up correctly. And what I'm going to do now is get some super glue and just put a little dab in each one of these top holes here, and it'll flow through and absorb around the metal and into the wood, and it'll do a really good job of holding each element in place. So just a little bit in each, not too much. You don't want to flood it all and fill that hole up. So the first set of elements are all glued in place, and if you take the time to tape it down and use 2 strips like this, it just makes life a lot easier. But they're all nice and straight and lined up, about as good as I can get it with my eye. So what I'm going to do next is cut the second lot of elements that's going to go along the top here and along the bottom. So I've got the elements measured and cut to size now, ready to glue onto the Yagi, but I just want to point out a couple of things when it comes to the measurements of the ones that are half the size. Now if you remember the back reflector, for instance, the back reflector is 63 millimeters long. Now half would obviously be 31.5 millimeters, but because these elements are sitting on top of the elements we've already glued in place, we need to take that into consideration and knock 2 millimeters off that measurement. So these ones that I've measured off here are only 30.5 millimeters long, and this is the reason why we need to knock off that 2 millimeters, because this wire is around 2 millimeters thick, and the second 2 elements are going to sit on top of that one. So because that's 2 millimeters thick, we need to knock that off the measurements for these 2 measurements, or these 2 elements are going to be too long. So that's why I've knocked off the millimeter off each length of the little elements here, and that's the same for the parasitic elements as well. They've each got a millimeter knocked off their length. And people have asked in some of the newer Yagi videos, but I've mentioned it in a couple of other videos previously, about the difference with Yagi antennas, whether to isolate the boom, not have it conductive at all so the parasitic elements aren't in contact with each other, or you know, Yagis where they're all metal and the parasitic elements are all joined together conductively, and whether there's any difference to that. And to be honest with you, at these frequencies, I've done some tests in the past and I can't see any difference, any gains for having one over the other. So you know, to make a boom that's non-conductive like this would, if I was to make the exact same Yagi out of you know, different materials, so they're all connected to each other, for instance, there's no discernible you know, increase or makes it any worse off by doing that compared to this. I don't know if there's a major difference to different frequencies. I don't know, because I'm not a ham radio operator. I've never used you know, equipment like that before in the past, so I don't know at different frequencies whether it does make a difference. But from what I've experimented with it, these frequencies, the higher frequencies, it doesn't make any difference at all. And again, I'm using the exact same method to glue the other elements in place. Got it tied down here with some masking tape, just a little dab of super glue in there, and then position that element in place, get it as straight as I can, hold it and let it set, and just work my way down the Yagi now, inserting all the elements in place. And as well, if you've drilled the holes in the boom by hand and you haven't got a few quite straight, choose your straightest ones to put your longer lengths in. And again, because this is a wooden dowel, it's got a little bit of give, so you can twist it a little bit. But with these ones along here, if your hole's not quite straight, you've got a little bit of play before the super glue actually sets. So again, you know, it's a little bit forgiving that way if you don't get your holes drilled out quite right. And to put the final row of elements in place, I've just got it lifted up on this roll of duct tape here. Does a good job of holding everything in place while I work on it. You may also notice that I've got my worst row of holes drilled in here. Quite a few of them are out a little bit, especially the reflector one here. But because I'm using this method, gluing each one in place, I can just super glue it in place and hold it vertical nice and straight until it sets. And that way I get round that problem of not having quite my drill holes lined up. And also this is with a drill press as well, so if they are a little bit wonky using it by hand, using a Dremel for instance, then as I say, doing this method it's a little bit forgiving, and you can straighten them up when it comes to gluing them in place. So now that all the elements are secure and glued in place, I'm now going to move on to making the driven element for this little Yagi. So to make the driven element then, the wire that I'm going to use to make it is this wire here. I've repurposed this out of some multi-core earth wire, and it's probably around 21 SWG. So I've got a length of the wire cut to one full wavelength at 2.4 gigahertz, which is 126 millimeters long, and I'm going to bend it into a circle shape, a round element, and you need to find something to bend it around. I'm going to bend it around this first, and then when I bent it around this, try and find something a little bit smaller, just so I bend it around and the two ends are about 2 millimeters apart from each other. You just want to find anything that you can use and progressively go down in size just to get a nice smooth round circle. So I've got the main driven element shaped there, and I'm going to connect to it using semi-rigid coax. Now, because this is a circle, it's going to sit up off the boom quite a bit there, and I've put this kind of swan neck into the semi-rigid coax already. I've also put some heat shrink tubing round here because I don't want the coax grounding down onto the reflector at the back here. Now, to support the ring of the driven element, I've made a circle here out of some cork matting. This is like 2 millimeters thick cork matting, and I've cut a slit in here quite wide and then opened it up into a circle in the center, so this will actually snap and click over the top of the boom. You could use some plastic or wood, something like that. Originally on the prototype I used cardboard, but if you want it to last you know, for a considerable length of time, you want to try and find something more substantial that's not conductive. And I've also put a mark where the main driven element needs to sit on this boom, and it sits 26 millimeters away from the reflector here. So if you get your ruler, measure 26 millimeters and then put a little mark there, you know where your element should sit. So I'm going to be directly soldering the two ends of the ring, one end to the center connector of the coax here and one end to the outside braid of the coax. So I'm just going to put a little bit of tin to the outside braid and tin up that center connector there. And then you want to tin up the two ends of the driven element, just get a little bit of solder on there. So now that we've got both ends pre-tinned, I'm just going to use my tip of my soldering iron here, get a little bit of heat, and then solder the first end onto that center coax there, and then the other end of the circle onto the outer braid. So now you can see how the main driven element is soldered in place, and you can just use the exact same method if you wanted to use flexible coax. So next I'm going to glue the cork support in place, and I'm just going to line it up with that little black line 26 millimeters away from the back reflector there, right in the middle of the cork support. So a little bit of super glue in there should hold it in place. So now that the support's glued in place, I'm going to feed the element onto the Yagi over those reflective elements at the back there, and what I'm going to do is glue the coax first down onto the boom there temporarily just to hold it in place, and then gently pull the element over the top of the cork, which might be a little bit fiddly. And then once you've got it over the top of the cork like that, I'm going to tack it in place just with some super glue just to get it nice and straight round there. And then finally I'm going to use some epoxy to make a more permanent connection for the main driven element here, and also the driven element onto the boom here. And really I should have made the boom a little bit longer at the back, because I could have made it a little bit longer here, and then I could have put some heat shrink tubing over the top of the coax and the end of the boom, and I've got a more secure connection here at the back. So if you do build one of these yourself from this video, I would do that, make that about 25-30 millimeters longer at the back here, and that way it'll really support your coax. But it's a little bit short here, but I should still be able to get a little bit of heat shrink tubing over the end there. So the little Yagi is now finished and ready for some paint. I've drizzled epoxy over the driven element just to really secure that down to the support there. I've also drizzled epoxy in between all the elements just to add a little bit of strength to them as well. You could have probably done a better job with some epoxy putty, but unfortunately I've ran out. I've drizzled a little bit of epoxy on the coax as well to secure that to the boom, and I've just got some heat shrink tubing around the end here to secure the coax down as well. But as I say, if you're going to copy this, I would make that boom a little bit longer just to add a little bit more strength to the coax. But as I say, I'm going to give this a coat of paint, and then we'll give it a little test, and I'll show you how powerful this is. It really is a nice little powerful design, this. So I just wanted to quickly show you on the network analyzer how wide a band this little Yagi will work over. Now the VSWR is 1.012, but it's a little bit it's fluctuating depending on how I move. It's really getting a lot of reflections here in the lab. The Yagi antenna is particularly sensitive to reflections and movement, and you can struggle to get a accurate VSWR reading, which is one of the reasons why I want to crack on and get my anechoic chamber finished off. But you can see the basically the response over the frequency. I'm sweeping from 2 gigahertz up to 2.7 gigahertz, and I've got the cursor on the best response there for the VSWR, and that's coming in at 2.47 gigahertz. So I'm just going to move it to the right, and you can see the cursor there is at 2.563 gigahertz, and that's still an acceptable frequency response, so it works quite wide over the band. So I'll just move it to the left, and again we're sat at 2.39 gigahertz, and again that's a very respectable frequency response. So it works over quite a wide area, and that's why a lot of people do like a Yagi antenna. It's one of the reasons why I want to perfect the 5.8 gigahertz one, especially for circular polarization, because it works over such a wide bandwidth. If you're setting up your transmitter, you don't have to worry too much whether what antenna you're using in your setup as opposed to the frequency you're using, because it works over such a wide band. That's something you don't really have to think about in your setup. So here's just a quick test then on the access points that you can get with this little Yagi, just from my window here in the lab. I'm not going to bother setting up another antenna to test next to it, but it'll give you an idea of how well it does perform. So I'll give it a scan. Just give it a minute to load up. So you can see there it's got quite a narrow beam width, has this antenna. It's not a wide beam width at all, because as I'm sweeping you can see some of those access points dropping out backwards and forwards as I'm sweeping there. But we've got a lot of green, a lot of good signal strength, especially when it's pointed at that access point. So a very impressive antenna for its size. So this has turned out to be a nice little design of a Yagi antenna then, and as you saw in that test, it packs quite a punch for its size. And what I'm going to do is I'm going to put the original one back together again, the one that we tore down to take a look at, and I've copied the measurements to come up with this design, and I'm going to take it outside over a much longer distance and give it a head-to-head test with this one. I do think the original one will have this slightly beat, but you know, I don't think this will be too far behind, especially when you consider it's like a quarter of the length of that one. And I think if I'd probably made this a little bit longer and put another set of parasitic elements on there, it would probably come very close to being very similar as far as gain is concerned. So I'll pop that back together again and do an outside test with this head to head. So I hope you found this video useful. Then it's not something that I would sell in its current state. It's still a little bit too fragile, and you know, it's still possibly classed as a prototype version of this. But if you want to make one of these for yourself, I'm pretty sure that in this state it would last quite a lengthy amount of time, as long as you didn't give it too much abuse. And hopefully you found it interesting how you get from something like this into something like that. And then when I do, you know, I'm looking at a way of a different method of making this to eventually hopefully sell in my shop, because this is a cracking little antenna, but it won't be until next year. And you know, then that'll be the third generation of this. So you can see how I get from a very simple prototype like this, find out it works, and then I've moved on to create something a little bit more substantial. And those of you who have followed me for some time will know that I really do like antennas that are powerful and have a small footprint. It's quite difficult to design a high-powered antenna with a small footprint. It's much easier, you know, if you're not taking the length, the size of it into consideration. You can just make an extraordinary long Yagi antenna, for instance. But to make something with such a small footprint and keep that high gain, it can really be a challenge sometimes. But this is quite a nice, easy design. It basically worked, you know, from the first time that I built this prototype. I didn't really have to do much tweaking to it. So if you did enjoy the video, please give it a thumbs up as always. Any comments or questions, drop them below, and hopefully you'll join me on the next one.